chain reactions. Now, what according to you is a chain reaction? Now, what according to you is a chain reaction? Who can tell me quickly without wasting time? As because I'm hard of time and I have to finish the class and I have another class thereafter. So please tell me
What class?
what class of reaction are chain reactions?
Complex reaction.
Please tell your name first. Who's speaking? Yes. Speak out quickly. Please see that our time is very important. It's only a 50-minute class. If you know, please speak out quickly so that we can proceed. I don't have to sit.
Yeah, sir. Chain reaction is basically a form of, it's like too many simple reactions which when combined in a single for a single reaction, then it's from a complex or chain reaction.
Many simple reactions combine to form a complex reaction. Do you mean to say this?
Yeah, yeah, sir.
So what do you mean? I mean, how do you differentiate between simple and complex reaction? Please tell me first this.
Uh, Simple reaction is basically like we have a rate defining rates, which is like basically constant to one reaction. But in complex reaction, it's like only one reaction which is outgoing so fast that one one constitutes of simple reactions gonna decide the factor or rate of that reaction. That's something I know.
Well, anybody else apart from him? What, according to you, is simple and complex reaction? Quickly, just tell me so that I can get a view of how much you know, so that we can go ahead with that.
Sir,
Yes, please, Rishabh.
yes, sir. Sir, simple reaction is that which uh, takes place only in one step, but complex reaction takes more than one step.
Sorry, I could not get you.
So a simple
Simple,
reaction takes place only in one step, and
okay.
complex reaction more than one
Complex reaction in
more than one step.
more than one step. Okay. Yes, that's right. Good. Now, the point is that a simple reaction, you can expect an overall reaction to be represented in a single step. The simple way to express a simple reaction is the overall reaction can be expressed in a single step. Henceforth, the rate determining step is the single step alone. The rate determining step is the single step alone. However, in a complex reaction, which constitutes of a mechanism whereby you have more than one steps involved. In the mechanism, you will find more than one step involved. Henceforth, you will have to look out for the rate determining step. All the different steps in the mechanism constitutes an overall reaction, and that is how you express a chain reaction. That is how you express a chain reaction. Now, one typical example is the hydrogen bromine reaction. Hydrogen bromine reaction is a photochemical reaction whereby you have both are in the gaseous phases, hydrogen and bromine, they together form hydrogen bromide. So it is actually H2Br2 that will lead to the formation of 2HBr. So that is how we look at. But let us first quickly revamp what is a chain reaction. I will read out a couple of lines so that you get to know. Now, such reactions in which highly reactive, that is transient or short-lived species, atoms or free radicals are produced. You know what is a free radical? Do you know about free radicals? Yes, do you know about free radicals?
Yes, sir.
Yes, Rishabh, what is a free radical?
Sir, it is neutral.
A free radical is a byproduct of the reaction which is highly reactive and has a very short lifespan. A free radical is a byproduct of the reaction that is produced as a result of an overall reaction which is short lived and highly reactive. It is produced soon after its production. It goes into the process of reacting with the other reactant molecule. So thereby it has a very short lifespan. So are produced as intermediates which carry the reaction at a rapid rate for for a long time. For a long time. Many gas phase reactions and liquid phase polymerization reactions are chain reactions. These reactions were first studied in the year 1934 by Franco Rice and Karl F. Herzfeld and are therefore referred to as Rice-Herzfeld chain reactions. So I would like to tell you that these two people were behind discovering what is called a class of complex reaction called chain reactions. An example of this includes gas phase pyrolysis, which is a high temperature decomposition of hydrocarbons, aldehydes. अरे कौन है ये? हल्ला मत मचाइए, थोड़ा क्लास चल रही है यहाँ पर अभी. So that is of hydrocarbons, aldehydes, several other carbonyl compounds, polymerizations, and reactions of hydrogen with halogens and oxygen. So this is basically a short introduction to what is called chain reactions. Now, as I was talking about this particular reaction, which is hydrogen bromine, so leading to the formation of hydrogen bromide, now it involves a five-step mechanism, five-step mechanism by way of which the entire reaction takes place. Now, before I proceed, I would like to inform that chain reactions proceed by way of different steps. Please remember, chain reaction take place by way of different steps. Now, what are those different steps? Number one, chain initiation. Can you please write down? Can you please write down, all of you? Can you please write
Yes,
down?
sir.
Okay, please write down that the different steps that are involved in chain reactions involve initiation, propagation, retardation, and ultimately termination. So you have these four important steps. How do you recoin these different steps? As number one, chain initiation, chain propagation, chain retardation, and chain termination. Now, what according to you is chain initiation? How do you define initiation? What happens during initiation? What happens during initiation? Yes, anyone? How do you understand initiation? Next is propagation, third is retardation, and fourth is termination. Initiation means if you have an initiator, then it allows the reaction to begin. You may have a reactant molecule, however, it finds it difficult to initiate the reaction. So you require some initiator to initiate the reaction. That is called initiation step. Number one is initiation step, and thereby the chain starts. The reaction starts. The reaction starts. So what happens is, as I said, that this is a class of photochemical reaction. So in presence of light, bromine molecule breaks down into two bromine atoms. This is very important, that since I am referring to bromine molecule, it breaks down into two bromine atoms, and thereby it initiates the reaction. Thereby it initiates the reaction. Now I find that this particular reaction has got two propagation steps. Now what according to you is propagation? Propagation means something that goes on without any hindrance. It goes on. It goes on so as to continue with the process of reaction. So as to continue with the process of reaction. So what happens to these bromine atoms that are formed in the first step? They undergo further reaction. First, it reacts with hydrogen molecule. So you have the bromine atom together with hydrogen molecule. It gives you an atom of hydrogen bromide and an atom of hydrogen. So it gives you an atom of hydrogen bromide and, in fact, a molecule of hydrogen bromide. I should not be saying an atom of hydrogen bromide. A molecule of hydrogen bromide together with an atom of hydrogen. And this a hydrogen atom which is formed in the third step, I mean in the second step, reacts with another bromine molecule to give you a molecule of hydrogen bromide and an atom of bromine. It gives you a molecule of hydrogen bromide together with an atom of bromine. Now, in the next step, which is supposedly called the retardation step, it involves the reaction of hydrogen and the molecule of hydrogen bromide. So what do you think it would give you? It gives you a molecule of hydrogen and an atom of bromine. And now you see that since you have already got, an atom of bromine, which is a signal that the reaction will no longer proceed further, will no longer propagate. Hence, this can be classed as retardation step. And now, if you take this bromine atom and if you have another bromine atom, two bromine atoms will lead to the formation of a bromine molecule, that is Br2. And you see the first step also has a bromine molecule, and the last step also has a formation of bromine molecule. A bromine molecule so formed is a signal to what is called the chain termination, which means that the chain finally stops, it no longer proceeds, it no longer propagates. So is it clear to you up to this point? Is it clear to you, or do you have a question to ask here? Did you understand of what I said?
Yes, sir.
Just please feel
Yes.
free. Just feel free so that just a moment. मम्मी धनिया पत्ता लेना है क्या? उसके पास है, बोल चिल्ला रही है। उसके पास धनिया पत्ता है, तुम मांग रही थी ना आंवला के लिए, लाई है। लेकिन जल्दी, ज्यादा हल्ला नहीं मचाओ। Can you all see this mechanism? Is it visible to you?
Yes, sir.
Yes,
Can
sir.
you see the mechanism that I was referring to, the 5-step mechanism? Please see if you are able to watch the mechanism that I am referring to.
Yes, sir, visible.
Okay, just see how it is written. Please make a note of how it is shared with you, how the first step is written, how the second and third steps are written, how the fourth step is written, and how the fifth step is written. So the point is that here you also note that each of these steps in the mechanism are represented by their respective rate constants. Important to note here is that each of these steps are represented by their respective rate constants K1, K2, K3, K4 and K5. Is that clear? Can you see that? Is it visible to you?
Yes, sir.
Yes, sir.
Okay,
Yes.
so what is the significance of representing each of these steps by their respective rate constants? Why do you have to write rate constants for each of these steps? Why are we writing the rate constants? What is the significance if we write the rate constants for all of these steps?
Sir, to determine rate determination step.
To determine rate determination step. Any other reply?
Sir, to calculate overall rate constant.
Okay, any other reply? Most importantly, since we are studying the kinetics of complex reactions, henceforth we have to show each of the steps in the mechanism by their respective rate constants. And it is true that at the end of the time, if we are supposed to calculate the rate, either the rate determining step or the overall rate expression, so we will require the rate constants for each of these steps. Okay, so we will show this as Ki, where Ki is equal to 1, 2, and so on to 5, because there are in total 5 steps are the corresponding rate constant for the different steps. In this chain reaction, the reactive intermediate is consumed. please note, in this chain reaction, the reactive intermediate is consumed, the reactants are converted to products, and the intermediates are regenerated. What is important to note here is the intermediates are regenerated. The regeneration of the intermediate allows the cycle to be repeated over and over again. So this is about what we can say, that this is all about the chain reaction. This is all about the chain reaction. बड़ा तंग करते हैं ये लोग, जो है इसी समय आते हैं ये लोग परेशान करने के लिए एकदम, नहीं तो दिमाग खराब हो जाता है इनसे। सुबह मत आया, सुबह मत किया कीजिए, मतलब इतना काम 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 बोला आप लोगों को थोड़ा धीरे। Okay, so as I said that you have here you have the different steps, and now according to you, if you are to identify the different steps, how are you going to identify them? कितना हो गया है? नहीं कितना हो गया, मतलब जो पूछ रहे हैं बताओ, दिमाग खराब। Okay, now please tell me if this up to this aspect, is it clear to you how you have to write the mechanism for chain reaction, how you have to express it kinetically? Is that clear? Say for example, if you
Yes, sir.
have a reaction, of the type hydrogen and bromine, which gives you a molecule of hydrogen bromide. So how are you going to derive the rate law expression? Most important. How are you going to derive the rate law expression? कितने की मटर और कितने की क्या है मतलब?
2 किलो मटर ये 65 की, हम 30 चलाए तो ये 65 के हैं।
30
की होती है
मटर तो 30 की ही तो लाए थे। हाँ,
और 10 का
कितना वापस किया है ये? कितना? नहीं, कितनी मटर कितनी है तो कितना हुआ 2 किलो? 70 रुपए। और उसके बाद 75 रुपए, तो कितना हो गया? 25 रुपए वापस।
ब्रोकली वाली चली गई, उनका सब कह रहे थे। ये पूरा
Okay, so how do you express it kinetically if you are to write it? And if you are to derive the rate law expression for this kind of chain reaction, if you are going to be writing the or deriving the rate law expression for this type of chain reaction, then how are you going to be writing it? How are you going to be writing it? Yes? Please speak out. We are running out of time. After that, after you, I have another class. Please speak out quickly. Yes? Have you understood my question? Have you understood my question?
Yes, sir, we have.
You have understood the question. Okay, now the point is that how do you represent if the question comes, derive the rate law expression for hydrogen bromine reaction. So what
So
is
so can you just do it once more? Some people have network problem. Can you repeat the question?
I'm saying, if you get a question of the type, derive the rate law expression for hydrogen bromine reaction. Usually such type of questions actually come in the examination. Derive the rate law expression for hydrogen bromine reaction. So I have showed you how to write the mechanism, which involves 5 different steps. So the first thing, very important thing, is to write the mechanism of a complex reaction in the form of different steps. Identify each of these steps by their respective rate constants of the type Ki, where I is the number, it denotes the number as 1, 2, 3, 4, 5, and so on. And then ultimately, if you are supposed to derive the rate law expression, what according to you would be the next step? How do you think you are going to be writing the next step? Yes. Yes, Arun Kumar. I can see that you are unmuting yourself, but you are not speaking anything.
Sir, change in concentration of that reaction by time equal to rate constant of that reaction into concentration of, तो जैसे आपने HBr बोला तो into concentration of HBr, hydrogen bromide.
Okay, okay. The point is that the first very important thing is that you have to understand is, if there is a buildup in the concentration of product, if there is going to be a buildup in the concentration of product, there has to be a simultaneous decrease in the concentration of reactant. Is that right? Do you all agree of what I'm saying? If
Yes,
there
sir.
is going to be a buildup in the concentration of product, there has to be a decrease in the concentration of reactant. You
Yeah.
have left hand side and you have the right hand side. A reaction looks like this. You have the left hand side, you have the right hand side, and if it is a class of reversible reaction, it will be denoted by 2 arrows If it is a reversible reaction alone, then it is a single forward step that is showing the overall reaction. Now the point is that what I said, kinetically it is true that there has to be a decrease in the concentration of reactants if there is going to be an increase in the concentration of product. So decrease in concentration, supposing if it is shown by a negative sign. Very important to note here is, if decrease in concentration is shown by a negative sign and increase in concentration is shown by a positive sign, this is very, very important. This is going to be considered as the next step. Then, supposing if I'm asking you that if you are going to be writing the, rate of formation, if there is a change in concentration of any of these species with respect to time, change in concentration of any of these species with respect to time, say for example, if I'm talking about dHbr over dt, what does it mean? If I say dHbr over dt, what do I mean by that? Who can tell me? dHbr over dt, what does it mean?
The decrease of concentration of HBr.
Rate.
See, yes, good. So the point is that HBr is a product of the reaction. Is it right? Hydrogen bromine reacts to form HBr. HBr is considered to be the final product. And if I'm saying dHbr over dt, which means the change in concentration of HBr with respect to time. Change in concentration of HBr with respect to time. So what are the reactant species? Hydrogen bromine. What is the final product species? HBr. So I am saying that I am looking only at the change in concentration of the product with respect to time, which is dHBr over dt. So if I am going to be writing the kinetic expression, if I want you to write the kinetic expression for dHbr over dt, and I have already defined decrease in concentration to be negative and increase in concentration to be positive. So how are you going to write the kinetic expression for dHbr over dt, which is the final product? What will you do if you are going to be writing the kinetic expression for dHbr over dt? Anyone? Yes? Please speak out, speak out. My time is running out. I have only 5 minutes with you now. I will not be sitting any further beyond 5 minutes. I will be leaving you as I have to attend my department also. Yes, please. A quick response is required if you want me to continue. Did you understand what I'm asking you? Did you understand of what I'm asking you?
Sir, please repeat the question.
How would you write the kinetic expression for dHbr over dt if decrease in concentration is represented by a negative sign and an increase in concentration by a positive sign? Yes?
Sir, minus dHbr by dt, positive dHbr by dt.
No, not all this. What will you do? Please see that every one of you should understand. I know you all know very much, but please see that I have a class comprising of 65 students. This is a class of 65 students, and I want each one of you to understand and follow up what I am asking. So please tell me, what will you do? Please tell me what will you do in order to write the kinetic expression? Have you understood what I'm asking you? All of you? Have you understood of what I'm asking you? Rishabh, have you understood? Shashank, have you understood?
No, sir, like that's something including me, like D, HBR, like D is like stand for what?
D
D is like,
stand for what D? Have you not studied mathematics? Have you not studied differential and integral calculus?
yeah,
Huh?
got it.
What kind of question are you asking? What is D? It is small d. It's simply like dx over dt. How do you write change in acceleration, change in speed? What is meant by change in rate? Any change in rate is with respect to time. Any
Yeah,
change in rate is with respect to time. Say for example, x is your distance. So change in distance with respect to time is, what is that? What do you count? Change in distance with respect to time, change in position with respect to time.
velocity.
Okay, good. Speed, velocity, momentum. So the point is that here I am referring to dHBr over dt, which means I am talking about the rate of change of concentration with respect to time. So this is what d is here. Now the point is that you will have to look carefully into the mechanism comprising of 5 steps and see each of those steps for where HBr has come. Please note, you will note down in all of those 5 steps where HBr has come. You will see if HBr is going to be consumed or it is going to be formed. If it is going to be consumed, it will be shown on the left hand side. If it is going to be formed, it will be shown on the right hand side. Formation is shown by a positive sign. Consumption is shown by a negative sign. So that is my question, that you will look up for all of those 5 steps where it is consumed, where it is formed. And then you will write the entire kinetic expression for dHBr over dt. Is that clear now? Is that clear now?
Yes, sir, it's clear.
It's clear. Please tell me, how are you going to write the kinetic expression now if it is clear? Please tell me quickly. Don't waste my and your time. Please tell me quickly, how will you write dHBr over dt? The entire kinetic expression.
So dHBr by dt is equals to K2 and K2 concentration of Br concentration of H2 plus K3 concentration of H and Br2 minus K4 H and HBr.
Excellent. Excellent. What's your name, please? Who
So Narayan.
spoke? Huh?
Narayan, sir.
Okay, excellent. Excellent. I wish that each one of you can speak the way he has spoken. That's right, completely right. There's no mistake at all. An excellent reply. And that's right. This is how you are going to be writing it for dHBr over dt. And this constitutes your kinetic expression for dHBr over dt. Excellent. Now, similarly, the next exercise would be to write the kinetic expression for dH over dt. Please note that I am referring to H. H means hydrogen atom. So likewise, you will look up for the left-hand side and right-hand side in all of the 5 expressions for its consumption, for its formation. Consumption is negative sign, formation is positive sign. So please write down and tell me for dH over dt, what will be the kinetic expression? Quickly, who can tell me before your time runs out? I find that you are left with only 2 minutes. The class will be winding in the next 2 minutes. Who can tell me? I think some of you have written down the expression for dH over dt. Yes. Yes, Sudipta, can you please tell me?
So K2Br H2 minus K3H Br2 minus K4H and HBr equals 0.
Excellent, excellent, Sudipta. Excellent reply. That's perfectly right. I would not ask you to add a zero right now. I will tell you, you are right. However, I need to talk about that also. So you need not to say zero right now. You just need to define the kinetic expression, which you have spoken correctly. There's no mistake at all, including the sign conventions that you have added. So this is a complete right expression, which she has spoken. I believe all of you have understood. Is that right? Everyone is getting like that? Or somebody is different from what she said? Please raise your hand if you have a doubt. As
No, sir,
because
it is correct.
it is correct. It is correct. And please note that we are moving on to derive the rate law expression for dHBr over dt. Now the next aspect, next exercise talks about deriving the similar kinetic expression for dBr over dt. Now the next exercise involves you to write the kinetic expression for dBr over dt. Can you please write it once again and tell me quickly? Who will tell me will get a reward from my side. Before your time takes out, please tell me to gain your reward.
So what was the question? Could you repeat? I couldn't hear it.
The way you derived it for dH over dt, can you do the similar exercise for dBr over dt? This time it is Br. The same way you will look out for all the 5 steps and draw the kinetic expression for dBr over dt. Can you do it quickly, Sudipta?
1 second, sir. 1 second.
I know you all have understood and you are doing the work. You are deriving, writing the kinetic expression. Please do it fast so that I can tell you what next.
So 2K1 Br minus K2 BrH2 plus K3H Br2 plus K4H HBr minus 2K5 Br to the power 2.
Excellent, Sudipta. Once again, excellent. Once again, excellent. With a slight mistake where at the very start, you said 2K1 Br. It's actually 2K1 Br2.
Okay.
It's actually 2K1 Br2. However, the entire expression which you said was right. Once again, you are right. An excellent reply. I believe all of you have written like that. Yes or no? Yes, please. Did you
Yes,
get
sir.
it for dBr over dt? Yes or no?
Yes, sir.
Okay, good, good. Each one of you, good. Now please see that you have all the species, the kinetic expressions for all the different species with you. And what are those species? Number one, the product dHBr over dt. Then you have the reactant species that comes as intermediates like dH over dt and dBr over dt. Now the point comes that you will be obtaining the concentration terms in fact for each of these species. For HBr, I mean HBr will form the complete rate law expression. However, you will draw it for Br and H. You will be drawing the concentration species for the Br and H. You are just going to be equating all these kinetic expressions to be equal to 0. As Sudipta has earlier mentioned, that you will be equating each of these kinetic expressions to be equal to 0. Can anybody tell me why do you have to equate each of these kinetic expressions to be equal to 0? Who can tell me?
Please repeat the
What is,
question.
yes, you equate
Sir, please
each of
repeat the
these.
question.
I can't hear Rishabh. Please speak loudly and be clear.
Sir, please repeat the question.
I have already said many times. I am asking that you equate each of these kinetic expressions to be equal to 0. Why am I asking you like that? What's the reply?
Because sir, it is an intermediate step.
It is an intermediate step. Any other reply? A good effort, Arun. A good effort. I cannot say that you are completely incorrect, but a good effort. There has to be something added in order to complete the
Sir,
answer.
because equilibrium.
Sorry?
Equilibrium.
I'm sorry, I can't understand.
Well, because
Yes.
everything is getting consumed, no formation or and there is no change in their concentration in the overall reaction.
I will tell you now. Yes, I mean, you are trying. Definitely, you are trying. The answer to that is that since this is a complex reaction, deriving the kinetic expression for a complex reaction can be too complex, as because there are so many intermediate species. So if we start looking at all these intermediate species and their concentration with respect to time, then it will be very, very complicated. It will be very, very complicated. So in order to avoid this kind of complication, what we do is that we nullify the these intermediate concentrations. We nullify into the final expression the concentration of these intermediate species, and we are only interested in our reactants and final product. So what we do is that we make an assumption that there is no change in the concentration of these species with respect to time. We make an assumption that there is no change in the concentration of each of these species with respect to time, which means that whatever, it will be equal to 0. Henceforth, we are equating each of these kinetic expressions to be equal to 0. And once we equate them to be equal to 0, our exercise becomes very, very simple. Our exercise becomes very, very simple. Now, I think I would like to leave you here. And in my next class, I will be talking further on beyond what I said, that we have equated all these kinetic expressions to be equal to 0. And I will be talking about why we have done this further in the next class, as because the time is up and I have to my department to attend. So I think I would like to leave you here, and I would give you time to just revisit the concept of complex reactions once again from your +2 books or whichever reference you find it easier to understand. So is there any particular question or query?